Welcome to the deep dive. We all see how fast the world of AI is moving. It feels like every other week there's some new model making headlines.
It really does. Almost hard to keep track sometimes.
But every now and then something just pops up, maybe from an unexpected place, and it really shifts how we think about what's even possible.
Exactly. I mean, the sheer volume is one thing, but some developments, they genuinely demand attention because they challenge the status quo.
And that's precisely why we're here today. We're doing a deep dive into an open source AI model called Kimi K2. It's developed by Moonshot AI, that's a Chinese company backed by Alibaba.
Hmm.
Our mission today is basically to unpack what makes this model such a big deal, especially for you listening, whether you're just curious about the cutting edge or maybe actively looking for powerful new tools. We're using a pretty detailed report on Kimi K2 to pull out the key stuff.
And what's really grabbing people, I think, is this core idea.
Yeah.
You've got an open source model that isn't just, keeping up, but actually outperforming some top proprietary AIs,
Yeah.
especially with complex things like coding and reasoning.
Right. That's the hook, isn't it? The idea that open source could beat the closed giants. Let's unpack that.
It's a potential game changer. Kimi K2 suggests maybe that future is closer than we thought.
Okay, so let's dive right into Kimi K2 itself. Its identity, its scale. You mentioned it's not just another LLM. What's the core difference?
Well, it's an open source mixture of experts, large language model, MOE for short.
MOE, right.
And the scale is, well, impressive. We're talking a trillion total parameters. But here's the clever bit. Only about 32 billion parameters actually activate per token processed.
Okay, hang on. A trillion total, but only 32 billion active. Explain that. What's a token again, just quickly?
Think of a token as like the smallest piece of text the AI looks at. Could be part of a word, a whole word, maybe punctuation. So Kimi K2 is incredibly efficient in how it uses its massive knowledge. It doesn't fire up the whole trillion parameters for every little thing.
Gotcha. So that MOE architecture, what's the single biggest benefit for, say, a developer listening right now?
It's about getting that top-tier performance without the crazy costs or lag you might expect from a model that big. The MOE approach is like, imagine a committee of specialists.
Okay.
The model figures out which specialists it needs for this specific task and only calls on them. So you get efficiency and the power of that huge underlying knowledge base. It's sort of the best of both worlds.
Right, so it's smart about resource use. And the open source part, what does that really mean for you, the user, in practice?
It means transparency. You can actually see how it works, more or less. Flexibility, you can tweak it, fine-tune it on your own data. And customizability. Researchers love it because they can dig in. Developers love it because there's no vendor lock-in, and it, fosters collaboration.
Okay, that makes sense. Now let's talk about one of its superpowers, apparently. The context window. I hear it's massive.
Oh, it's huge. 128,000 tokens.
128K. Wow. What does that actually let you do?
Well, think about it. It means the AI can keep, like, an entire book's worth of information active in its mind while it's working on your request. Or maybe a whole software project's documentation.
So for really long documents, complex coding projects.
Exactly. Or multi-step workflows where context is crucial. It won't just forget what you were talking about 5 minutes ago, which can be a real issue with other models sometimes. It's a massive leap for maintaining context.
That sustained memory sounds key. And I heard something about its training stability being unusual too. How did they manage to train something this big without it, breaking?
Yeah, that's another big innovation. They use the unique optimizers called mu-on-clip or key-clip. Now, that sounds technical, but the upshot is it allowed them to train the model stably using an absolutely massive data set, 15.5 trillion tokens, without the training process becoming unstable or failing.
15 trillion. Wow.
Yeah. So that means the model has a really robust and reliable foundation. It's built to handle enormous amounts of data without those common training hiccups you see with other really large models.
So a solid foundation allows for specialization. And that brings us to the different versions or variants of Kimi K2, right? How are they tailored?
Correct. There are basically two main ones you should know about. First, there's Kimi K2 Base.
Base, okay.
Think of that as the foundational engine. It's powerful, it's the core model. Ideal for researchers or maybe companies that want to take it and really customize it, fine-tune it for their own specific needs and data.
The raw power, got it.
And the other one?
That's Kimi K2 Instruct. The report calls it tuned for agentic use.
Agentic. Okay, break that down. What does agentic mean for you, the listener?
Agentic basically means it's built to take action. It's been specifically refined for things like tool calling, using external tools or APIs, plus complex reasoning and sort of back and forth chat. It's designed for fast, almost reflex-like output.
So less like a chatbot, more like an assistant that can do things.
Yeah.
Exactly. It's the ready-to-use version, optimized for actually automating tasks. For a long time, AI was great at talking, but actually doing things in the digital world or interfacing with other systems. That was the tough part. Kimi K2 Instruct takes a big step there.
That ability to do things sounds like the really exciting frontier. How does Kimi K2 actually achieve that? How does it learn to use tools?
Well, it was trained on a massive amount of synthetic data, specifically designed around tool usage, across thousands of different potential tasks or domains.
Okay, so it learned by example, essentially.
Yes, but it also uses reinforcement learning with something called self-critique. So it tries to perform a task, assesses how well it did, and learns from its own attempts to get better at planning and executing those actions over time.
Learning from its mistakes, basically. And this autonomous tool invocation they mention, what does that actually look like? If I want the AI to say, book a meeting.
Right. It means if you give Kimi K2 the definition of a tool like Access Your Calendar API, it can understand your request. Book a meeting with Sarah at 2 p.m., figure out it needs to use the calendar tool, call that API with the right information, and potentially even confirm it back to you, all on its own.
Wow.
It's a big step towards AI that doesn't just answer, but interacts with other systems, manages data, automates workflows, real actionable intelligence.
Okay, that sounds incredibly powerful. But let's ground this in some numbers. The benchmarks. You mentioned it shines in coding.
It really does, especially for an open model. Take SWB Bench it, verify that's a tough benchmark for fixing real software bugs. Kimi K2 got 65.8% on a single try.
That sounds high.
It is. And with multiple attempts, it hit 71.6%. Now, compare that to, say, GPT-4.1, which scored around 54.6%. Kimi K2 is right up there, close to models like Claude Sonnet 4.
Outperforming GPT 4.1 on that specific task. Okay. Any others?
Yeah, on Live Code Bench V6, which is about solving coding problems live, it got 53.7% pass at 1. That's the best score reported for any open source model on that benchmark.
So leading the open source pack in coding, what about other areas like math or general knowledge?
Also very strong. On the Math 500 dataset, it achieved a staggering 97.4% accuracy. That's state-of-the-art for open models in math.
97%. Okay.
And strong scores elsewhere, too, like A, which is a hard math competition, 49.5%, MMLU-EM for broad knowledge, 89.5%, MMLU Redux, another reasoning test, 92.7%. The numbers are consistently impressive across the board, especially for STEM and reasoning.
So these aren't just marginal gains. For someone listening, what's the real takeaway from these scores?
It means this isn't just hype. These numbers translate into genuine effectiveness in complex technical areas. If you're building apps that need serious coding help or scientific analysis or deep reasoning, Kimi K2 shows that open source models are now genuinely competitive at the highest level. It really changes the landscape.
That's huge. Okay, so it's powerful. How easy is it for someone to actually get their hands on it, to try it out or use it?
Accessibility is actually one of its strengths, thanks to being open source. The model weights themselves, they're available on Hugging Face.
Hugging Face, okay. Standard place for models.
Yep. And under a modified MIT license, which is quite permissive, for actually using it, there are APIs available through services like Novita, Grok Cloud, Deep Infra. And these APIs are designed to be compatible with the popular OpenAI or Anthropic API formats.
Oh, so potentially easy to swap into existing projects.
That's the idea. It lowers the barrier to integration quite a bit.
What about running it locally? On your own machine? Possible.
It is possible, yeah. People are using tools like Llama.cpp.
Yeah.
And there are quantized versions available.
Quantized meaning smaller, more efficient.
Exactly. Compressed versions designed to run on less powerful hardware. But let's be clear, even the quantized versions need significant resources. We're talking around 250 gigabytes of RAM or VRAM for full local inference. So it's possible, but not exactly for your average laptop yet.
Right. Substantial compute needed. But there are cloud options and platforms like Caltine or OpenRouter 2.
Correct. There are multiple pathways depending on your needs and resources. That flexibility is a big plus.
Okay, benchmarks are one thing, specs are another. What about actual people using it? What's the feedback from the community?
It's been really positive, actually. I saw one quote from a developer that stuck with me. They said, "I love the way this model produces responses. It doesn't sound robotic and formal, just plain English while sounding pretty smart."
That's interesting. So not just capable, but the output feels natural.
Apparently so. That suggests a certain level of polish and usability that isn't always there, especially with highly technical models.
Yeah, that natural language feel is important.
Definitely. And beyond the tone, people testing it on platforms like Line are confirming that those strong tool calling and coding benchmark scores, they hold up in practice. It seems to actually deliver on that agentic promise. It's not just a lab result.
Good to hear that real-world validation. Okay, as we sort of bring this together, let's summarize. What are the key advantages of Kimi K2 that listeners should really remember?
Okay, core strengths. Number one, its performance. Leading the open source field in coding, STEM, and that agentic tool use stuff. Number two, the huge 128K context window. Massive advantage.
Right.
Number three, the open weights and permissive license. That means transparency, flexibility, customization. And number four, underpinning it all, is that stable MOE architecture with a special muon clip optimizer, ensuring it's robust even at that trillion parameter scale.
Solid list. And the flip side, current limitations people should be aware of.
Well, main one right now is it lacks native multimodal support. So it doesn't directly process images or audio out of the box. It's primarily text-focused.
Okay, no vision or audio yet.
Not natively, no. And as we mentioned, that local inference still requires pretty hefty hardware, even with quantization. That's a practical barrier for some.
Got it. Provides a balanced picture. So knowing all that, let's talk practical applications. If you're listening, how might you actually use Kimi K2? For just plug-and-play chat or getting it to use tools via an API, you'd probably go for
Kimi K2 Instruct. That's the one fine-tuned for immediate use for those agentic tasks.
And if you're more of a researcher or you want to build something really custom on top of it,
Then you'd start with Kimi K2 Base. That's your foundation for deep customization and fine-tuning.
okay. And for running it offline, locally, assuming you have the hardware.
You'd look for a quantized version and use something like llama.cpp. Just double-check those RAM requirements first.
Good advice. What about developers? Integrating it into their coding environment.
Again, the Instruct variant would likely be the go-to, leveraging its coding and tool use skills directly within an IDE, potentially.
And finally, for building bigger systems, maybe orchestrating multiple AI steps.
Those tool calling APIs are key. You can embed Kimi K2 as a smart component in a larger pipeline, having it call other services or run code as needed.
It really sounds like Kimi K2 marks a pretty significant moment for open-weight AI, doesn't it?
I think so. It's this combination of, massive scale, that trillion parameter headline, but also the smart MOE design, and crucially, that demonstrated proficiency in complex tasks like coding and tool use. It's a potent mix.
Yeah, it feels like more than just an incremental step.
And its performance, especially beating established players like GPT-4.1 on certain benchmarks, combined with the open access, it really positions Kimi K2 as a serious contender, particularly for developers or companies who value transparency and the ability to customize, maybe want to avoid vendor lock-in, or are looking for cost-effective power.
A top contender, but open. That's the key difference.
Exactly. It challenges the idea that you need a proprietary black box to get state-of-the-art performance.
So let's leave our listeners with a final thought then. Given Kimi K2's power, especially in coding and these agentic tasks, and the fact that it's open, how might this rapid rise of powerful open source models fundamentally change things like software development or business automation? Could we see less reliance on those closed proprietary systems for really critical stuff in the coming years?
It's a really interesting question to ponder, isn't it? What happens when this level of capability becomes openly available, adaptable, and potentially much cheaper? It could really reshape the landscape. Something to think about.